Alright, using properties of tangents in Chapter 10. Chapter 10 we're going to learn about circles. Circles have a center, a diameter that goes through the center of the circle from one side of the circle to the other side of the circle. We have a radius that is started at the center to the end point on the circle. And then you have a chord, which is like the diameter but does not go through the center. What you also have is a secant, which is a line that crosses the circle at 2 points. And then you also have a tangent which crosses the circle at exactly 1 point. It is denoted by a point. Here it is the point of B, which is called the point of tangency, and another point that is not on the circle. Tell whether the line, rate, or segment is described as a radius, chord, diameter, secant, or tangent of circle C. So, segment AC. A to C is a radius because it starts on the circle and ends at the center of C. So segment AC is called the radius. Ray DE, if I start at D and go through E, I hit the circle at 1 point of B, with it hitting exactly at 1 point, it is called a tangent. Segment AB is starting on the circle and ends on the circle. It's a segment, it goes through the center of the circle, so it is called the diameter. And line AE, A to E, hits the circle at 2 points, so point A and point G. So since it hits at 2 points, it is called a secant. Finding the radius and diameter of a circle, you got to go from the circle center to the outside. The cool thing about the radius is it is half the diameter, or the diameter is 2 times the radius. So circle B, center, going 1, 2, 3. The radius is equal to 3, so diameter is equal to 6. A, the radius is equal to 2, so diameter is equal to 4. Now, points of intersection. You can have points of intersection that are coplanar circles. You can have 2 points of intersection, 1 point of intersection, or no points of intersection. Those points of intersections are through common tangents. So you will need to draw them all out. Note that every single one you draw, you need to use a straight edge because it's a lot easier to see. So common tangents are where you hit each circle only once through one single line. So, theorem 10.1. In a plane, a line is tangent to a circle if and only if it is perpendicular to the radius of the circle at its endpoint on the circle. So line M is tangent to circle Q if and only if line M is perpendicular to the radius of QP. In the diagram, segment AB is the radius of circle A. If BC is tangent to A, is BC tangent to A? What you would have to do is look at this as a right triangle. It is a Pythagorean theorem, so you would need to check to see if the Pythagorean theorem holds true. In the diagram that S is a point of tangency, once again, you are looking at it as well. In this case, though, on your radius, you are looking at T plus 36 squared equals T squared plus 48 squared. Now, we will also be looking at doing this one, setting it up. 25 squared equals 25 squared plus 60 squared equals 67 squared. If that holds true, then it is a point of tangency at point B because it forms a right angle, which is perpendicular, which means Pythagorean theorem holds true because it's a right triangle. Homework will be listed on the board. Try your best on it. We will cover anything that we need to cover also on Monday.